that means we have a trash talk. But today, we're going to have a doc talk. And the reason we're going to have, we can trash some things if you want. I mean, this is your show, really. I'm just on the ride. We can trash things if you want. There's lots to trash. But today, I want to talk more about cytokines.
Okay.
So, because we talked about last week, and I can't remember which video it was, but we talked about how obesity and COVID-19 going together is not a good combination. And why? Because they said what percentage, I can't remember what percentage it was, but there was I think it was 90-something% of the individuals who have died from COVID-19 are also obese.
Yeah, but obesity goes with other health problems.
A lot
diabetes,
of things.
high blood pressure, heart disease, dyslipidemia.
But they have all those other things, usually because
of obesity.
They're obese.
Mm-hmm.
So
that's correct.
We talked about last week, during this conversation, we talked about a cytokine storm. So what I wanted to do today, because you mentioned that, and then I looked it up, and then I became fascinated by how cytokines work.
Mm-hmm.
Because I read that Forbes article that I think you also read, or you'd seen it too. And I wanted us to dive deeper into that because I think it's kind of fascinating. So can you explain exactly, so the virus hits your system, you have your first layer of protection your body has for fighting viruses, germs, etc. Then you have your second layer. Can you explain, so we're talking about just in general how people's bodies work, but also these individuals who are obese not having as good of a fighting chance. And cytokines. I'm probably not doing a good job setting you up, but you can figure it out.
Just want me to start talking?
Yeah, just start talking.
Well, your first line of defense is always your skin. And space and avoidance and stuff like that. So that's your first line of defense. I think your second line of defense is your body's own immune system. So if you have any circulating antibodies and you have a really robust immune system, to where you really don't get infected with much of anything. And don't get confused with a good immune system, which means with me, I'm not allergic to poison ivy, but some people are extremely allergic. That has nothing to do with whether or not you're going to fight an infection good or not. But some people have really deteriorating immune systems. And I think not so much obesity is a big factor, but age. And the older we get, the more our immune system forgets. Mm-hmm. And I might have said this on a previous video, and I'll say it again. It was go back to the tetanus shot. The question we always ask when people come to the emergency room, when was your last tetanus shot? Okay, well, here's this gets kind of interesting. You say, well, you need to have one every 10 years. Well, here's the sticky wicket of it. If somebody comes in and they have what looks like a tetanus-prone wound, and don't sit here and say, oh, it's the rust on the nail. That has nothing to do with it, okay? Tetanus really can't, it likes the iron, but it has to be in the soil, okay? It's what we call an anaerobic bacteria. It can't be exposed to oxygen. It does not live hardly at all in oxygen. So it's in the soil. You step on a board, there's a nail in the ground, punctures you, nail pulls out, the hole is sealed behind you. So now you have an air-free environment for tetanus to survive. Well, if you've never had a tetanus shot, giving you a tetanus vaccine at that point in time does nothing. I have to give you a thing called TIG, tetanus immune globulin, which is made from the pooled plasma that people are given for the coronavirus. And I can give you that shot. It's about 250 units, and you're going to be fine. Now you actually have immediate antibody protection against tetanus. At the same time, I'm going to give you a tetanus shot. Okay, we've all had those, the ones you're supposed to get every 10 years. But you don't develop immunity to it for about 7 to 10 days. It takes your body 7 to 10 days for it to regroup and recognize it as a foreign antigen, build up antibodies to it, and launch a response. So that's part of it too. Mm-hmm. In the elderly, it takes us longer. We just don't have the robust immune system to process this information quickly. I think if they got exposed to little samples of viruses over time, they would develop immunity. It would just keep re-challenging and re-boosting it. Mm-hmm. And that's why we even take pneumonia shots. I got a pneumonia shot, it's just a pneumonia booster. So hopefully I don't come down with pneumonia, but if I do, I have a shot that prevents a lot of that stuff. So it develops your antibody system real quickly. People that are obese have tendency to have diabetes, which is a big killer for immune system, because it has a lot to do with cortisol, steroids, and other things. And high levels of sugar has been well documented to lower the immune system. I think to have underlying body inflammation, okay, from high blood pressure, stress, diabetes, different types of cancers will increase your body's inflammatory response, and inflammation is what really does a lot of harm to the body.
Mm-hmm.
So, underlying vascular disease, I think is going to be shown to be more inflammatory than it is cholesterol. I always thought the cholesterol thing was a little bit overboard. So, but these are all things that really make you predisposed to have a bad reaction to a stupid virus.
So now I read a little bit about it, and this was last Friday when I read about it. So basically, we talked about the T cells.
Yes.
And we talked about cytokines. And
Right.
there is a specific action that they take in your body. The way I thought about it was almost like a SWAT team. Like a SWAT team goes into a house. We'll call what's inside the house. The house is your body. What's inside the house is the virus. The SWAT team bursts in.
So the virus is the burglar.
The virus is the burglar.
Okay.
The SWAT team bursts in, and it's looking for the virus, correct?
Mm-hmm.
And what the virus tries to do is hide
Behind everything else.
It's trying to get away. It's trying to hide so that it's not seen by the T cells.
Mm-hmm.
So what I read about the coronavirus is it likes to hide in your lungs. That part I wasn't sure why it wants to hide in your lungs.
What's a respiratory virus?
Yeah,
And
but
there's
it
not
says that
there's not a lot of immune reaction going in your lungs.
and that's why it goes there, because it's
It can
not
hide
as
in the
easy
tissue.
to be detected
Correct.
by the SWAT team that was sent in to handle the problem. So what
I like this SWAT team
isn't this
thing.
a good, because this is how I had to say it in my head, so I remembered. So now the cytokines job, basically, they're also to assist the SWAT team, correct? So then what they're supposed to do is go in, identify the thing that needs to be killed or whatever. I shouldn't
Put a
say
badge. The cytokines put a badge on the burglar
Yes.
and say, kill that
And
one.
say, kill that one. But what happens is they just decide to kill everything.
They put badges on
They
everybody in
put
the house.
badges on everything. So it's just like it's like all your cells are getting slaughtered instead of the right ones. So the good guys and the bad guys
Yeah.
are getting taken down.
Think of it as this way. One of your cells that wants to fight this virus sends out an alert and alerts all the other
Yeah.
cells. Fight everything.
Dispatcher.
Fight everything.
Yeah.
Kill everything.
Yeah.
Immediately.
Yeah.
And it just unleashes hell in your body.
Yeah, and that's what ends up wrecking people. Is
It does.
that basically your body is just wrecking everything.
It is. It's too much inflammation, and the younger people can tolerate a lot of inflammation, but the elderly, they cannot, and they literally drown in their lungs.
Yep.
And they drown quickly. I mean, it's really, I'd like to say it's fascinating, but it's not. It's tragic. But
Yeah.
some of the case studies I've been reading about the coronavirus, where they think, oh my gosh, this person's finally turned the curve and they're going to be able to discharge home. They're dead 2 hours later.
Yeah.
I mean, they just
And
go,
that's
boom.
the cytokine storm.
That is.
So when if you go back to our video last week, we talked about a cytokine storm. So what we just explained with the SWAT team example, that's basically a cytokine storm. The cytokine's job is to assign to the
Target.
T cells what they need to get. So
But they get overwhelmed and you just target everything.
they target everything.
Yeah. And I think that's where a lot of this research is going to come out with this virus about new therapies to prevent something like that.
Yeah.
So it'll be interesting.
Yeah, but do you think that there's going to be a lot of research into how to help the cytokines identify things correctly, or just in general?
I think the first thing that you're going to see is what that's going to be called a cytokine inhibitor.
Okay.
To inhibit the T cells from releasing too many cytokines and releasing too much
Okay.
inflammation at one time. So
Don't
calm
attack
it down.
everything.
Correct.
It's not saving the day, but it's also not wrecking your body.
Right.
Okay.
So we want to protect the body first and foremost, and then
Okay.
I don't know if cytokines are really bizarre. I mean, you're talking very
They're signaling cells, is what they call them,
are,
correct?
They are, and so there's going to be all kinds of different receptors and cross-reacting receptors. I mean, this is a little bit complicated. So there's a whole lot more
Yeah.
to this, but in a nutshell, you did a good job of
Yeah.
explaining it.
You could even explain it maybe even like traffic signaling. if all the traffic signals in the world were saying we're doing their job and you over here can go, you have to stop. It's like everyone go, and then there's wrecks everywhere. Could also be kind of explained like that too. So basically your body's just not doing a good job signaling what needs to happen next. So it just terror ensues.
It's crazy, Michelle.
It's awesome it's not awesome in that way, but it's awesome how your body tries to protect itself, and it's interesting how our bodies are incredible.
It's the thing you were talking about too, is which I found along the same lines is that what they call the coagulopathies, to where these people were having clots, but yet they were trying to give them medicine to keep her from clotting, and it wasn't working, and they were still clotting some more, and that's a whole nother pathway that we don't even understand. Yeah. This is something brand new to us all.
I have 2 things I think I want to talk about next week, and it's COVID toes and clotting related to COVID. Because there's a couple things that I found about that I thought, well, that is crazy. This whole thing is terrible, but it's incredibly interesting to see how our bodies respond to a new virus that we never knew about before.
And I do think we're going to find a bunch of new therapies because of it.
Yeah, I think there has to be some new breakthroughs in technology that maybe have a lot to do with COVID and maybe has nothing to do with it, but solves another problem that we've never even understood how to solve before as a result. So there could be, like you said, some silver linings, unfortunately, because of this. Mm-hmm. All right, everyone. I think we did it. What do you think?
Wasn't trashy, but it was okay.
Wasn't trashy, but it's interesting.
Yeah, I miss my trash talks.
Well, I'll try to find something to trash. But at this point, I mean, all we have is COVID-19 to talk about.
I mean, that's my favorite day, Tuesday.
I know. We'll find something to trash.
Okay.
I'll figure it out.
Yeah.
If you guys have something you'd like to know.
I'm going to have to start getting back on my Prozac.
Well.
Because I'm going to be depressed.
I recommend that anyway. All right, everyone. Well, you have a great week. We'll see you Friday for feedback.